For this experiment, you will need a Millikan oil drop apparatus, a voltmeter, and a high voltage power supply. Now this power supply is actually made up of two separate power supplies, one connected to a light bulb that will illuminate the chamber where the experiment will take place, and the other half of the power supply is for the set of parallel plates used in the experiment. Now this Millikan oil drop apparatus comprises basically four parts: an atomizer that will be used to charge the latex spheres and inject them into the chamber, the set of parallel plates where the experiment takes place, the microscope to view inside that chamber, and a light source to illuminate the very, very small latex spheres inside the chamber. Now, the particles used in this experiment are very, very small latex spheres. We put a few drops of the latex sphere solution into the atomizer, a little bit of distilled water, and the latex spheres are injected into the chamber through this tube and this nozzle. Now, here's the bottle of the latex sphere solution, and as you can see on this bottle, the manufacturer's label says the diameter is 1.02 micrometers, and the density of the latex spheres is 1.05 grams per milliliter. To inject the latex spheres into the chamber, we squeeze the bulb of the atomizer, and this will inject a few dozen latex spheres that become charged by friction through the tube into the chamber. Now the small latex spheres are injected into the chamber that contains a set of parallel plates. Here's a close-up of the chamber, and the distance between the parallel plates is 3.8 millimeters. Now, looking through the microscope into the chamber where the experiment takes place, you can see in this field of view about 10 or so latex spheres. In this field of view, the latex spheres are all falling down because they have reached their terminal velocity. You'll also notice the lines on the microscope eyepiece. These lines are used for references of the latex sphere's motion. This switch on the side of the apparatus has three positions. The middle position, the parallel plates are basically disconnected from the power supply. When the switch is in the up position, the top plate of the parallel plates will be charged positive. This is the position we will have it in when we do the experiment. So here's trial one of the experiment. We've introduced the latex spheres into the chamber by depressing the atomizer bulb. You can see in this field of view about a dozen latex spheres. You might have to focus the microscope to pick up the spheres. Flipping the switch on the side of the apparatus to its up position will make the top plate positive. Some of the highly charged latex spheres will move. You can see the one latex sphere in the field of view now, and the task now is to adjust the voltage to bring this latex sphere to rest. You can use the lines on the microscope as references to make sure that the latex sphere is not moving up or down relative to those reference lines. Now, once you've adjusted the voltage to the objects at rest, you can read the voltmeter. You can see here it's 134.5 volts. Now here's trial 2 with a new latex sphere in the chamber, and again adjusting the voltage to bring the latex sphere to rest, again relative to those lines on the microscope. And when you've got that object at rest, you can read the voltmeter. In this trial 2, the voltmeter reads 27.4 volts. Now here's the last trial in the experiment, trial 10, again with a new latex sphere injected into the chamber and adjusting the voltage to bring this latex sphere to rest relative to the reference lines on the microscope. And as you can see, the voltage required to bring this object to rest is 22.6 volts. Now, from this video and the worksheet that accompanies this video, determine the charge on the latex spheres in all 10 trials, and from this information, determine the smallest possible charge in nature, the elementary charge.